Hello friends, welcome back to my channel. So in this session, we are going to take up a question from theory of computation. Yes, we have discussed a previous question which was from GATE 2020 theory of computation wherein we had to draw a DFA with constraints. So I'm just modifying this question a bit because some of you asked me to show the possibility if the question had an OR constraint instead of the AND constraint which it had. So this is the particular session dedicated to the OR constraint possibility of this particular question. Now, in GATE 2020, students, you need to see that in that question they asked you to draw a DFA with AND constraint, and there might be a possibility that this time in GATE 2021 they give you a question with an OR constraint. So therefore, in that perspective, this video offers you an important insight. So let's dive into the question and let's see how we solve this question. So over here we have the same question number 51 from that GATE 2020 set which I downloaded from IIT Delhi website. You can have a look on the same question paper. So it says that consider the following language: L equals to L equals to X equals to X belongs to A comma B combination. So X is a combination of A and B. Uh, so X is basically a string with alphabets A and B, number wherein such that the number of A's in X is divisible by B but not divisible by 3 was in the original question. I have changed it to that A's in X is divisible by 2 or not divisible by 3. Okay, so yeah, so I've already made a video on this particular question wherein I have solved the question for number of A's in X divisible by 2 but not divisible by 3. So you may please refer to that video. I'll put that in the suggested videos in the same, and you can see that video. You can have a look at that video, and that is also very important. And now in this session we are going to take up the OR possibility. So in the same way as I solved the previous one, so basically here they asked about the minimum number of states in the DFA which satisfies the above condition, which accepts the strings belonging to the above language. Okay, so now we are going to solve this question with the OR perspective. Again, I have jotted out the conditions given in the question to me. The conditions were divisible by 2, or now with the new perspective, not divisible by 3. Okay, so if you just go through that video, my previous video, we already drew this DFA for A is divisible by 2. So what was the basic logic used behind solving the this question? So I said that it will be very simpler if we drew the DFA for these individual constraints and then combine both of them, right? So first of all, in that video we had drawn the DFAs for the DFA which is for A is divisible by 2 and then A is not divisible by 3. So this is the DFA that we had drawn for A is divisible by 2. You can please view my previous videos to know that how we reached to this DFA and this DFA. This is for A is divisible by 2 and this is for A is not divisible by 3. Now uh, in that video we had combined them using the AND constraint wherein we had you know multiplied, basically in some sort of way we had multiplied the states. So to combine they had actually been augmented, but in mathematics you would say multiplying the states. Actually obviously we are not actually multiplying the states. So over here, as I said, I had answered in the comments that you'll combine using OR. So you'll add a new state such as Q naught and combine both these DFAs. See, this is the first DFA, this is the second DFA. And if I just, minimize it a bit, yeah. So this is the first DFA over here, this is the second DFA, and I have just combined them using a new state Q naught and epsilon moves, right? So therefore there is a possibility that I might go over here or over here. So any of these could be the initial state, Q1 or Q3. And you know what, this entire thing is same as this, and yeah, this entire thing is same as this. That is what I'm trying to say. And I've just combined both of them using epsilon transitions from a new state Q naught. So that is the basic logic how we combine the two DFAs using the OR constraint. Now this is not the DFA, as you all know. This has now become an e-NFA. Yes, e-NFA. So the final step now involves the conversion of this e-NFA to DFA. So as you can as you can already see that I have uploaded a video for this procedure, how to convert an e-NFA to DFA. You can please go back to that, review the basics. That is a very basic, concept how to convert e-NFA to DFA, and I have shown the entire procedure with a very simple example. And now we are going to implement that using this particular case. Okay, so next step is to convert e-NFA to DFA. So as I've already discussed that in detail in that video, I'll be just covering the important things over here. So I'll be just moving on to the transition table first. So first step over there, what we did was we drew the transition table of the existing e-NFA. For my current example, I do not require that. I can do that without, I can, move to the, I can form the DFA without using that e-NFA transition table. So I'm skipping that step. So the next thing, the next step over there was that we found the e closures. So yes, we require the e closure for what? For choosing the starting state of our DFA, of our new DFA. So yes, I am finding the e closure of my new starting state, which is Q naught. So what is the e closure? I'll be basically finding out which are the all possible states that I can reach by an input of epsilon, right? E stands for epsilon. So now since it is an e closure of Q naught will definitely be coming out there. So Q naught I've written. Then by giving Q naught the input of epsilon, I'm able to reach Q1 as well as Q3. So I've written Q1 and Q3 over here. Then if I give epsilon as input to Q1, there is no transition, there is no epsilon transition. So there is no state that I can reach by giving input epsilon over here. Similarly, it goes for Q3. If I give input epsilon over here to Q3, I won't be able to reach any other state. So that means we are done with the E closure of Q naught, and this forms the starting state of our DFA. So now I am starting to build the transition table of my DFA. Sorry about this. Yeah, I was just trying to zoom in a bit. Yeah. So the transition table of the DFA, the starting state would be what? The starting state would be the same that we just find out over here, that we just got over here, E closure of Q naught. So that I've written over here. Next, what was the step? Next step was you just give the inputs, these inputs, you just give these inputs to this state and find out what are the new states that you get. So that is what I'm going to do over here. When I feed input A in Q naught, what do I get? Nothing, because Q naught only has epsilon transitions. So then I move to Q1. If I give input A to Q1, I reach Q2. So I've written Q2 over here. Okay. Then when I give A input to Q3 over here, when I give A input to it, I reach Q4. Therefore, I've written Q4 over here. Okay. So we have checked with Q0, Q1, Q3 all. So we are done with the A input for this. Now same thing we'll be doing with B input. So when we do for B input, when we put B input in Q naught, again there is no transition with B from Q naught, there are only epsilon transitions. So we skip for this, we move to next state, which is Q1. Then when we give B as input to Q1, we reach the same state, Q1. So Q1 written over here. Okay. Then similarly for Q3, when we give Q3 the input B, what state do we reach? We reach Q3, right? So in the similar manner, you will be now repeating this step again for the new states that you have obtained. Yes, these are new states, right? Q2, Q4, Q1, Q3. No state is repeating. In our previous example that we discussed in the previous video of conversion of e-NFA to NFA, one of the states had repeated. And I had also discussed it there that if both the states would have been new states, I would be repeating this step for both the new states one by one. So that is what I've done over here. I am first of all taking Q2, Q4, then I'll be taking Q1, Q3 and finding out the new states by inputting these inputs A and B. Okay, so now when I, in the similar manner, let me do it once again with you, and obviously then you can complete the transition table yourself. So over here, when I give input A to Q2, what do I reach? When I give input A to Q2, I reach Q1. So therefore, I would have written Q1 over here, yes. Then Q4, when I give input A to Q4, this is Q4, input A given, I reach Q5. So I would have written Q5, yes. So this is the new state, okay. Then I'll be taking this again over here, and I'll be checking which are the new states. Now Q2, Q4 with B input, Q2, Q4 with B input, Q2 with B input, Q2, Q4 with B input, Q4. So Q2, Q4 again. Now this repeats, so we'll not be taking it again. Okay. Now in the similar manner, you are going to complete it with Q1, Q3. Okay. And when you process Q1, Q3, you see there is no new state which has been obtained over here. But when you process with Q1, Q5, you reach another new state which is Q2, Q3. So I take it over here again, Q2, Q3. When I process with Q2, Q3, I reach another new state which is Q1, Q4. I take it again over here. With Q1, Q4, I reach another new state which is Q2, Q5. I take it again over here. But with Q2, Q5, I do not obtain any new state. I obtain Q1, Q3, which has already been covered over here, and Q2, Q5, which is the same state. Okay. So therefore, the procedure ends over here. Now, which are the final states out of them? The final states are the one which contain the final states from our e-NFA. Now, which are the final states in our e-NFA? They are Q1, Q4 and Q5. Q1, Q4, Q5. So the states in our DFA which contain Q1, Q4, Q5 will become our final states. Q1, Q4, Q5. So this becomes our final state. Okay. Q1, Q4, Q5. Final state, Q4. Final state, Q4. Q1 because over here. So final state, Q1. Final state, Q1, Q4, Q5 are not here, so not a final state. Q1, Q4 both, so final state. Q5, final state. So then the final step is just to draw a DFA corresponding to this transition table. You just need to form the draw the transitions, and this is the final DFA that you'll obtain. Now, if I just try checking my constraints over here, the constraints were either the DFA should contain A's divisible by 2 or A's not divisible by 3, right? Now let's take some of the strings. Over here, first, this is the initial state as well as the final states. And what is this state forming? This is forming an empty string. So yes, empty string, the strings will be divisible by 2, so it is acceptable. Now it would have not been acceptable if there would have been AND over here, because 0 would be divisible by 3. It has to be not divisible by 3, but since it is OR, so this is acceptable. Okay, then when we reach over here, it forms A, right? It forms A. The shortest string which is forming is A. Now A is not divisible by 2, but it is also not divisible by 3, and since it is not divisible by 3, it is satisfying one of the conditions. Therefore this string is acceptable. This should be accepted, and this is what it is. accepting over here. Okay, then over here when we reach the string b. Now b is containing no a's, zero a's. Zero a's is again divisible by 2. So in this manner you can, you know, validate this DFA. You can check that all the strings that you'll be getting will be satisfying are this combined condition, which is combined by or. Okay, so that's all for this session, students. This is really important because you might get a DFA with all constraint this time. So I highly recommend that you practice this session, and if you have any doubts, any problems in this question or any related questions, you can please post them as comments in the comment section below. So if in case you have any extra doubts related to other topics, you can again post them as well in the comment section below. In case you like this video, please like it, and if you have not subscribed till now to my channel, please subscribe it and also press the bell icon so that it helps me to keep you informed with my new videos. And students, please keep practicing, keep learning, and I'll be back with some more questions. Till then, stay tuned. Thank you.